Hello, my name is Brad. I'm with the Canada Masonry Design Center, and today I'm just going to be showing you quickly how to design an out-of-plane wall using the Walls module in Mass. So when you open a new wall, selecting New Wall from the Welcome screen, this is the screen you'll be taken to. All of your inputs are here, your results are shown down here, and your wall will be shown here. So to start, all we need to put is a height. So I'm just going to put in a 6-meter wall, so 6,000 millimeters, and you'll see as soon as I put a height in, the drawing is shown here. One important thing to remember is that when we're looking at designing out-of-plane walls, the Mass does everything in a per meter basis. So you can see this blue shaded area in here, and then 3.2 meters, which is shown here. A lot of people call or email asking, why is this number grayed out? The reason is this 3.2 meters is really just an illustrative length. If we only showed 1 meter of wall, you wouldn't be able to really see different bar spacings, especially if you're looking at spacing your bars further apart than 1 meter. And so that's why we made that decision to show more of that. But really, all of the calculations are done on a per meter basis. So once you have this wall, you've put your height in, you'll see right away this loads input button has been enabled. So I can click there and input my loads. Now just remember that all of these loads, while the units, if I'm putting like a lateral line load on my wall, I'm just going to put a load of 1 and I'll change this to a wind load. Once I have that, you'll see it's a kilonewton per meter. Really, that's applied laterally on your wall as a kilonewton per meter per 1 meter of wall. So if you have a load in kPa that you're applying to a large area of wall, you can directly translate that over and put that in as 1, if it were 1 kPa, 1 kilonewton per meter, and that's applied in 1 meter of wall that you have. Now if I wanted to add an axial load, for example, I'll just put a dead load on here, and I'll change the type to an axial load, and I will just put this on as 10 kilonewtons, once again per meter of wall. And so now I have a lateral load, I have a vertical load. I'll also add a live load, axial load. I'll make that 10 as well, and I'll add a snow load on here, axial load. Now it's important to remember with the Mass software, we are just designing an element of a structure. So whether you model this as pin where you fix the base, all depends on the other assumptions involved in that. The loads as well are not distributed to the walls using the software for the out-of-plane module. This is something that you do yourself, and so all of the assumptions and all of the numbers that you use, that you put into this module, Mass will design for. And so any assumptions regarding like tributary areas, if you have, let's say, a large door on one side of a wall that you were designing, you need to take into account that you have a larger tributary area and scale up your loads accordingly, just to take that into account. So now that I have these loads in here, I can select all these so that you see them all in the drawing. I can click on the moment and deflection design, which is now being enabled. And once I click on that, what happens, Mass is cycling through all the different possibilities, starting with the smallest, weakest masonry unit and the least amount of reinforcement, and working its way up to a larger size. So now you can see, when we're finished, the boxes that are shown in green, this is the design that's actually being used in the wall. So we're using a 20 centimeter, 20 MPa unit, 1 bar per cell, and we're putting number 20 bars every 4th cell, or every 800 millimeters. Now you'll see here the shaded region, the B effective, that is your effective compression zone, and that is based in the S304 on 4 times your thickness. Now if you were to look at your effective area per bar, 4 times 190, that's 760 millimeters. You'll see that's 950 here. That's because that 760 is per bar, which is spaced at 0.8 meters. So you need to divide that 760 by 0.8 to get the 950 divided that you see there. So I just quickly did that on my calculator in front of me. So yeah, 760 millimeters divided by 0.8 meters, which is the spacing, that gives you the 950 that's shown here. That's another common question that we get quite a bit. So you'll see here, once we've done that, we've designed for a moment. There are a number of results you can see here. So those are the loads that we were looking at before. We also get reactions. There's your moment diagram for a pin wall and your deflection. And one that is really useful is the PM diagram. So whenever you design in Mass, those loads that we entered are all unfactored. And what happens is we get a large number of load combinations. I can zoom into this here so you can have a better idea of what's going on. And even here, the number of load combinations we're looking at is very high. If I look at my simplified moment results here and scroll down, you can see all of the load combinations that are attempted, and you can actually see the slenderness calculations done for each one. So we start out with the primary factored moment, that MF there, and then if you look over here at MF total, these are the numbers taking slenderness into account. So if you look over here at the PM diagram, you can see these values with the larger moments. Those are the ones that use wind, and then these bars they represent the amount of that slenderness has affected that load combination. So you can see load combination 9, which we can go back and find it in our results here. 1.25D plus 1.4W plus 0.5 of the live load. That is this value here, and I can actually click on that value to see all of the values in this diagram as well, so you don't have to look through this table every single time. So that is the load combination with the highest axial load, and then it also gives me the highest factored moment taking slenderness into account. So that's a quick way to visually see what's going on with your wall. Now if I go back and look at my wall, once I have completed a moment design, you'll see that the Shear Design button is highlighted here, so I can click on that. Mass will quickly go through, it'll check my wall for out of plane shear. Now if my wall were to fail, there's not a whole lot you can do for out of plane walls, unlike shear walls where you can put bond beams or joint reinforcement in. For an out of plane wall, generally you can either put more grout in your wall, or you can use a stronger or larger masonry unit. And so if this wall were to fail, what would happen is the software would try and increase the block strength and size in this input area here, and then when that happens, it would go back, check it for a moment, and then show the results here. So sometimes going from moment to shear, your design might change if it needs to change for your shear results. Now bearing, you'll see, is still disabled even though we have a successful design. That's because the bearing design is just limited to, like, it only makes sense to do it for beams. So for outer plane walls, this is a complete design we've designed for moment, deflection, and shear. And like always with the results, you can look at your moment results, your deflection results, as well as the same for shear. And then if you want to look at the detail, you can click on this detail tab while having the moment selected. It takes a little minute to bring up all the equations, and then you can look through at everything that the software is doing and how it gets its results. So it shows these results for the critical load combination. So that would be load case 9 that we looked at earlier. And then you can do the same for deflection. So for detailed, you can see all of the values that were used as well as the equations, and the same thing for shear. So I hope you enjoyed this video. This is the complete out of plane wall design, and if you have any questions, please feel free to give me a call or send me an email through the Mass support email. Have a great day.